Yeah, welcome back. All right, so we're going to do your homework for day one of the chain rule. So let's take a look here. This is saying to take the derivative of this expression, radical x to the fourth plus cosecant x. So how do we want to view this? Well, like we said in the past, we want to view this as a composition of two functions, the outer function being the radical, the inner function being what I put in that orange box. So we're going to view this as radical stuff. Now, before we get to it, let's just recall when you do a problem like this, you want to recall the structure of rules that you know. So, for example, you know the derivative of radical x. I had mentioned you should memorize it. It's just 1 over 2 radical x. So, if you know that, if that's your derivative rule, you can apply this now. You can apply the chain rule to this. So, in other words, the derivative with respect to x of radical stuff, it's going to be the same structure. So instead of x, it's stuff. So it'd be 1 over 2 radical stuff. And then you just multiply by the derivative of stuff, which I'll call stuff prime. Now, usually you pick up a math textbook, they're not putting the word stuff in there. We do it a little bit more eloquently. We'll say, hey, if you want to find the derivative with respect to x of radical u, right, where u is a function of x, it's going to be 1 over 2 radical u, and then times the derivative of u, so times du dx. And this is applying the chain rule to this known derivative rule. And you can do that for any known derivative rule. Basically, replace the x with the u, and then multiply by the derivative of u with respect to x. So going back to this problem, if I was going to do it, right, I would say, all right, I view this as radical stuff. So the derivative is 1 over 2 radical stuff. Don't mutilate stuff. Don't change it, right? Stays the same. And then times the derivative of stuff. Now, stuff happens to be a sum. The derivative of a sum is the sum of the derivatives. So the derivative of x to the fourth is 4x cubed. And the derivative of cosecant x is going to be minus cosecant x cotangent x. Now, if I left it like that, it would be incorrect because it's 1 over 2 radical stuff times the derivative of stuff. So all of this is times the derivative of stuff. If the derivative of stuff happens to be more than one term, you need to wrap it up, right? These parentheses are vital, otherwise it's wrong. And so now there's really not much sprucing you can do here. You can basically write this as a single fraction and get 4x cubed minus cosecant x cotangent x, and then all over 2 radical x to the fourth plus cosecant x. That's a 4 there. All right, and that's it. And that's what you get. So there's your slope producing machine, right, for the graph of radical x to the fourth plus cosecant x, otherwise known as your instantaneous rate of change producing machine. And we're doing it using a chain rule. All right, so let's keep going. The more you do these, the better you get. So it says find dy dx if y is equal to cosine of tangent of x. So again, this first off, this isn't cos times tan x, right? Cos doesn't exist, right? This is cosine of tangent of x. So in your head, you're like, all right, the derivative rule I want to recall is I know the derivative of regular old cosine of x, right? That derivative is negative sine x. So using that now, I can apply the chain rule. Instead of x, I have stuff. So that means I know that the derivative of cosine of stuff, which I'll just call u right now, that's going to be negative sine of stuff times the derivative of stuff. And that's just me applying the chain rule to a known derivative rule. So when I go to take the derivative of this, I would ask you, hey guys, how do you view that? You'd say we view this as cosine of stuff. So the derivative is going to be negative sine of stuff. Don't mutilate stuff. Negative sine of stuff, and then times the derivative of stuff. Well, stuff is tangent x. So the derivative of tangent x we have memorized is secant squared x. And that's it. There's no sprucing you can do here. All right, this is negative sine of tan x times secant squared x. So pretty basic. All right, let's take a look at this guy. Find the derivative, find f prime of x for f of x is equal to that stuff. So in this particular case, it probably would behoove us to rewrite this. So remember, raising something, or actually I should say cube rooting something, is equivalent to raising it to the 1/3 power. So this is like x squared minus 1 quantity squared, and then instead of cube rooting all of that, I can raise it to the 1/3 power. And better yet, power to power, I'd rather write this as x squared plus or minus 1, I'm sorry, right, raised to the 2/3 power. Just multiply 2 and a third. So that's nice and clean. And maybe just emphasize what we did here, right? We do this a lot when we're taking derivatives. Sometimes you want to rewrite f before you actually apply a rule. So now I'll do this one more time and then I'm going to stop doing it. So now what's the structure I see here? I see stuff to the 2/3. So in your brain, you're like, all right, well, the regular old rule, if I had x to the 2/3, right? The derivative of that power rule, it's just 2/3 x to the subtract 1. So subtract 3 over 3 from that. So it would just be that. So that's the derivative of x to the 2/3. So you're like, all right, well, how do I apply the chain rule now? Well, applying the chain rule to that known derivative rule, I would say, okay, what's the derivative with respect to x of stuff to the 2/3? Where I'm just, instead of writing stuff, I'm going to write u. Well, it would be 2/3 stuff to the negative 1/3 and then times the derivative of stuff. That is the chain rule, rates of change multiply. So now when I come over here, I would ask you, hey guys, how do you view this? And you would view this as stuff to the 2/3. So when I go to do the derivative now, it's going to be 2/3 stuff. Don't mutilate stuff. Don't change it. It's 2/3 stuff to the, you have to subtract 1 now from this power. 2/3 minus 3/3, right? Minus 1 is going to be negative 1/3. And I'm putting that in blue because everyone forgets to do that when they start doing the power rule with functions, with the chain rule, I should say. And then times the derivative of stuff. Well, stuff happens to be a difference, and the derivative of a difference is simply the difference of derivatives. So the derivative of x squared minus 1 is simply going to be 2x, right? If stuff was a product, I'd have to use the product rule. If stuff was a quotient, I'd have to use the quotient rule, right? So you can't forget the rules that you already know. Now, in terms of sprucing this up, I mean, I don't know. What can we do? We can multiply the 2, maybe put the x in front because multiplication is commutative. So maybe I write 4/3 x and then x squared minus 1 to the negative 1/3. Now, that's fine. I'd leave that as an answer. If it's multiple choice, they might mess with you. You might have something like this, right? The 4 and the x. I'm going to put that up top. On the bottom, I have that 1/3, so there's a 3 there. And then maybe they have this to the 1/3 power using properties of exponents, negative exponents. Or better yet, maybe instead of raising that to the 1/3, they have the cube root of x squared minus 1. Again, you don't have to do this, but you should know how to do it in case it's a multiple choice, right? All right, rocking and rolling. Let's take a look at 4. 4 says, all right, find dy dx for y equals secant squared x. So now I've said this in the past when doing evaluations, but I'm going to say it when finding derivatives too. When you have shortcut notation like this, before you take the derivative, you're going to want to rewrite it, right? So that's my advice to you. So rewrite this as y equals what it means. It means secant x quantity squared, right? Definitely want you to do that. So now how do I view this? I view this as stuff squared, right? So this time I won't actually show you the whole thing in my brain, right? I'll just do it. So what is the derivative of stuff squared? Well, it's going to be 2 times stuff to the 1 and then times, that's where the chain rule comes in, the derivative of stuff, right? Well, remember, this was stuff. So the derivative of stuff, the derivative of secant x, I have that memorized. It's secant x tangent x. And that's what I would get from calculus. And now I can spruce this, right? Raising to the 1 power is not doing much. Secant x times secant x is going to be secant squared x tan x. And that's just a little bit of sprucing, if you will. All right. And that's it. All right. That's using the chain rule. All right.